What is filter order in IIR filter design? Have you ever wondered how filters in digital signal processing work? One key concept that plays a significant role in this is filter order in infinite impulse response filter design. So, what exactly does filter order mean? In the context of infinite impulse response filter design, filter order refers to the highest degree of the polynomials in the filter's transfer function. This specifically relates to the order of the denominator polynomial that defines the feedback part of the filter. Essentially, it tells us how many previous output samples and input samples are used to calculate the current output. To break it down further, an infinite impulse response filter is defined by a difference equation. This equation relates the current output to past outputs and current and past inputs. The filter order indicates how many of these past samples are involved in the calculation. For instance, if a filter has an order of 3, it uses 3 previous outputs and/or inputs to determine the current output. Now, why does filter order matter? It affects several important aspects of filter performance. First, higher order filters can achieve a steeper roll-off between the passband and stopband. This means they can filter signals more precisely, which is often necessary in various applications. However, increasing the filter order also introduces challenges. More poles and zeros are added to the filter's transfer function, which can complicate the design process. It may become more difficult to stabilize and implement the filter efficiently. Additionally, higher order filters requiring more calculations for each output sample, which can impact real-time processing capabilities. In practice, engineers often use cascaded second-order sections, known as biquads, to construct higher-order filters. Each second-order section corresponds to a filter order of 2. By cascading multiple sections, engineers can achieve the desired overall order while maintaining stability. When choosing the filter order, engineers consider the required specifications. These include passband ripple, stopband attenuation, and transition bandwidth. Generally, an infinite impulse response filter requires a lower order than a comparable finite impulse response filter, making it a more efficient choice in many cases. In summary, filter order in infinite impulse response filter design is a fundamental aspect that defines the filter's complexity and frequency response. It corresponds to the number of poles and zeros in the filter's transfer function and is typically implemented using cascaded second-order sections for better stability and efficiency. Understanding filter order can help you make informed decisions in signal processing and control systems.